Welcome to the lecture on solving equations by factoring. In this set of notes, we're going to be solving polynomial equations of degree 2 or more. So the steps that we're going to follow when we see a degree 2 polynomial is to remove any parentheses or grouping symbols, combine any like terms, and basically clean up the equation first, unless, of course, the equation initially already has the form a times b equals to 0. So clean up parentheses, clean up any like terms, and try to get it into a nice form. Once we have it all cleaned up, we're going to get all our terms on one side of the equation and set it equal to 0. This is really, really important. You always want to get a 0 on one side of your equation. Once you have your 0, then you're going to factor using all of your strategies for factoring. And once it's completely factored, you're going to set each factor equal to 0. And that should enable you to solve the equation, and you can check your solutions if you have time. So for example, you might see something like 16y squared equals to 25. So first thing I'm going to do, there really isn't anything to clean up here, so I'm going to go ahead and get my 0. So we can do that by subtracting 25 to the left side. 16y squared minus 25 equals 0. And now once you get your 0, you're ready to try factoring. This expression on the left side has no GCF. We have two terms, and both of them are perfect squares, 16 and 25, and we have a difference in between. So this is a difference of squares pattern. So to factor this, I'm going to set up my two sets of parentheses. Square root of 16y squared would be 4y and 4y. Square root of 25 would be 5 and 5. One's plus and one's minus. Now we're going to set each expression, each factor, equal to 0. So 4y plus 5 equals 0, and 4y minus 5 equals 0. To solve these, they're just basic linear equations, so I can subtract 5 to the other side and divide by 4. So one solution will be negative 5/4. And for the other equation, I'm going to add 5 and divide by 4. So our second solution will be positive 5/4. Another option for writing your solution would be y equals plus or minus 5/4. And there we have our answer. Now on this next example over here, you want to be really careful. It's tempting to set x plus 8 equal to 0 and x minus 2 equal to 0 because it's already factored on the left-hand side. However, there's no 0 on the right-hand side, so you're not allowed to set each factor to 0 unless you have a 0 on the right. So unfortunately, even though this problem has some nicely factored forms on the left side, we're going to have to undo all of that and get rid of all these parentheses just so that we can add that 21 into the mix and get a new 0. So if I FOIL out the left-hand side, we're going to get an x squared, we're going to get a minus 2x, a plus 8x, and a negative 16. Now let me combine some like terms. Negative 2x plus 8x is 6x. And now we're ready to get our 0, so I'm going to add 21 to the other side, and that gives me x squared plus 6x plus 5 equals to 0. Now we have our 0, so now we're ready to factor. This polynomial on the left side has 3 terms, so when we have 3 terms, we're going to try that reverse FOIL, and this is the easier case because the leading coefficient is 1. So I'm going to set up my two sets of parentheses. I know that I need an x and an x in the front, and then for the second positions, we just need two numbers that'll multiply to 5 and add to 6. And the only choice is 5 and 1, and if I make them both plus, then I'll get that positive 6 in the middle. So now we have it factored completely. We're going to set each factor to 0. And if we do that and subtract 5, we're going to get negative 5 and negative 1. So x is negative 5 or negative 1. Okay, on the next example, it's kind of like the last one. Even though it looks really nicely factored on both sides, unfortunately there's no 0. So we're going to have to undo all of this nice factoring by foiling this stuff out, get rid of the parentheses, move everything to one side so we can get that 0. So on the left side, if we FOIL, we're going to get 2x squared plus 10x plus 1x plus 5. On the right side, if we FOIL, we're going to get x squared, 3x plus 11x plus 33. Now let's combine some like terms. On the left side, we get 10x squared plus 11x plus 5. On the right side, we get x squared plus 14x plus 33. And now we're ready to get a 0, so I'm going to subtract all the terms on the right side over to the left side. And that will give me a positive leading term, which is always nice when you're trying to factor. And we'll have our 0 on the right-hand side. So 2x squared minus x squared is x squared. 11 minus 14x is negative 3x. And 5 minus 33 is negative 28. So again, we have 3 terms on the left side. So to factor this, we're going to use that reverse FOIL, 2 sets of parentheses. This is the easier case because my leading coefficient is 1, so I just need x's in the front. And now I need 2 numbers that will multiply to negative 28 and at the same time add to negative 3. So that has to be a 7 and a 4. And I need the larger number to be negative so that the middle term will be negative. So I want a minus 7 and a plus 4. Now if we set each factor to 0, I'm going to get positive 7 and negative 4. So my 2 solutions are 7 and negative 4. Okay, on the next example, we have no parentheses to get rid of. We're ready to just jump right in and get our 0. So I'm going to subtract 64y over to the left side. So that gives me 25y cubed minus 64y equals 0. Now this has 2 terms, and 25 and 64 are nice perfect squares. However, y cubed and y are not nice perfect squares. So you can't use a difference of squares pattern on this yet. However, if you notice that since both terms have a y, we can factor out the y as a GCF. So that's what I'm going to do. I'm going to pull out y. That decreases the power on this y down by 1. So I'm going to have a 25y squared left over. And I lose this y, so I just have my minus 64. Now if you look at what's left, we have a nice perfect square, 25y squared, because that power on y is even, and 64 is a nice perfect square as well. So we are left with a difference of squares. So we're not quite done factoring yet. We can break this up. I'm going to leave my y out front, put my 2 sets of parentheses. Square root of 25y squared is 5y. Square root of 64 is 8. Make one of them plus and one of them minus, so we have no middle term. And now we're completely factored. So all we have to do now is set each factor to 0. Don't overlook the y that's out front. That y, because it has a variable, needs to get set to 0. So one solution that we're going to get is just y equals 0. Another solution we're going to get, when we set 5y plus 8 to 0, subtract the 8, divide by 5, so we also get negative 8/5. And if I set the third factor to 0, we're going to add 8, divide by 5, so we get positive 8/5. So my 3 solutions are 0 and plus or minus 8/5. One thing to keep in mind when you have polynomial equations is look at the degree on the equation. This was a degree 3, so it makes sense that we're getting 3 solutions. And this is called the fundamental theorem of algebra, that you're going to have as many solutions as the power on your degree. And sometimes they're not always real numbers, but you should always have as many solutions as the degree if you consider complex numbers as well. Okay, in our next example, we have 4 terms on the left-hand side. So when you think about how you're going to factor 4 terms, remember that technique of factoring called grouping, and this is ideal for that when you have 4 terms. So the way grouping works is you group together the first 2 and the last 2, and between just the first 2 terms, what would our GCF be? Well, we have a p cubed and a p squared. so I can factor out a p squared from both terms. From the first term here, I would have the 2 left over and 1 more p. And if I pull out all of these p squareds, then the only thing I have left is a factor of 1. From the second two terms, what do they both have in common? Well, if you do a little checking on your calculator, 49 goes into 98 2 times. So 49 divides into both of these terms evenly. And notice they both have a minus sign as well. So I'm going to factor out a negative 49. If I do that, negative 49 goes into negative 98p 2p times. And negative 49 goes into negative 49 exactly 1 time. It's going to leave me with a positive 1. Remember, you can always redistribute back to double check that you factored correctly. Now, we're not done yet. In the grouping method, it's actually a 2-step process. Once you group your two terms together, what you should be left with in these parentheses should match exactly if this is going to work. These two match. So I'm going to pull that factor of 2p plus 1 out, just like it was a GCF. And if I sort of imagine crossing them off because I factored them out, what I'm going to be left with is a p squared minus 49. Now here you have to be careful because we're still not done factoring. What's left over here? P squared minus 49. P squared and 49 are both nice perfect squares, and we have a difference in between. So this is a difference of squares pattern. So we can factor some more. Leave the 2p plus 1 out front, and we're going to set up our 2 sets of parentheses. And I need a p and a p in the front, 7 and a 7 on the back, 1's plus, 1's minus, and now we finally have it completely factored. So we're going to set each factor to 0. If I solve the first factor, I'm going to get p is negative 1/2. If I solve the second factor, I'm going to get p is negative 7, and the third factor gives me p is positive 7. So my 3 solutions, this was a cubic, remember, is going to be negative 1/2 or plus or minus 7. Okay, on this next example, there's no GCF. We have 3 terms, and notice that the degree of the middle term is exactly half the degree of the leading term. And that's a good thing because we have 3 terms here, so we'd like to try a reverse FOIL, and it's going to work for us probably as long as this middle term power is half of the leading term, and we can get our coefficients to work out. So since we have 3 terms, I'm going to set up my 2 sets of parentheses, and this middle term, that y squared, is the clue to tell you what needs to go in these front 2 positions. Since I have a y squared in the middle, I'm going to need a y squared in the front here and a y squared in the front here, and just double checking. Y squared times y squared is y to the 4th because you add exponents. So that does check out. That is going to work for us. Now we need 2 numbers that multiply to a positive 16 and add to a negative 8. Well, 16, 4 times 4, so I can use some 4's here. If I make both of them negative, negative 4 plus negative 4 will be that negative 8. So this is how we factored initially. Are we done factoring? Well, not quite. Y squared minus 4 is a square minus a square. So each of these 2 factors are difference of square patterns again. So both of them are going to break down a little bit further. So if we factor y squared minus 4, it's going to become y and y, 2 and 2, 1's plus, 1's minus. For the second factor of y squared minus 4, we get exactly the same thing. Y and y, 2 and 2, plus or minus. So this factors now completely into 2 factors of y plus 2 and 2 factors of y minus 2. We're ready to set them to 0. So if I set this to 0, I'm going to get negative 2. If I set y minus 2 to 0, I'm going to get positive 2. And these 2 factors over here are just going to give me the same 2 solutions. So my answer is plus or minus 2. Now we only got 2 solutions, even though this was a 4th degree polynomial, but that's because these were what we call repeated values. They were repeated roots, so we had these solutions occurring twice. For the remaining portion of the notes, we're going to focus on some word problems that you're going to have to set up an initial equation and then solve it just like we practiced in the earlier problems. So all of these word problems, the hard part is going to be setting up the equation, and then we're just going to solve it by getting our zero, factoring, and setting each factor to 0. So in this next example, we have the hypotenuse of a right triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 1 foot less than twice the length of the shorter leg. Find the leg of, find the length of the shorter leg. So we're talking about a right triangle. So let's draw one. And in our right triangle, remember the hypotenuse is always the side that is directly opposite your right angle, and it's going to always be the longest side of your right triangle. So we have the hypotenuse over here, then we have a shorter leg and a longer leg. Doesn't really matter which one is which, but I'll just label them like this. Hypotenuse over here, short leg over here, longer leg over here. So we are told that the hypotenuse is 1 foot more than twice the length of the shorter leg. So given that sentence, which side of the triangle would we like to know first so that we can determine the other one? In this case, if we know what the shorter leg is first, then we just need twice that plus 1 more, and we'll have the hypotenuse. So since we need to know the shorter leg first, call that one x. And then the hypotenuse is going to be twice that plus 1 foot more. From the second equation, or second sentence, it says the longer leg is 1 foot less than twice the length of the shorter leg. So again, we need to know that shorter leg first, and then the longer leg will be 1 foot less than twice the shorter leg. So twice the shorter leg is 2x again, and then we want 1 foot less than that. So the longer leg should be 2x minus 1. Now, to get an equation that relates all of this information, you need to know something from geometry called the Pythagorean Theorem. And what the Pythagorean Theorem says is the two legs of a right triangle, which we typically call A and B, these should be the two sides that form the right angle, and the hypotenuse C, there's a relationship always between these three sides of a right triangle. And what the Pythagorean Theorem says is that A squared plus B squared always equals C squared. So the two legs squared and summed, or squared and added, always equal the hypotenuse squared. So that relationship exists up here as well. All we have to do is translate this into this Pythagorean theorem equation. So these two sides, the short side and the longer side, are my legs, the A's and the B's. The hypotenuse is the C, so 2x plus 1 is going to be my C. So what the Pythagorean theorem says, according to our dimensions here, is that our leg over here, what I'll call x, what I called x, that squared, plus my other leg, which we called 2x minus 1, quantity squared, has to equal the hypotenuse squared. Notice that I'm using parentheses because we need this entire expression squared. Alright, so this is the hard part, getting that equation. Anytime you're solving a right triangle problem, almost always you're probably going to be using the Pythagorean theorem. So here's our initial equation. Now we need to solve it. So to solve this, you have to clean it all up first. We've got lots of parentheses here, lots of squares that we're going to need to FOIL out and sort of expand out, and then we're going to move everything to one side, get a 0, and then try to factor from there. So to start with, let's expand out and square these two quantities. So I'm going to leave this x squared where it is, and if I FOIL this out, don't forget to FOIL, you're going to get that 2x quantity squared, which is 4x squared. You're going to get a 1 squared, which becomes positive 1, and the middle term is these two multiplied together, doubled. So 2x times 1 is 2x. When I double that, it becomes 4x. Since we had minus in between, our middle term is minus. Now, if you don't remember that pattern of squaring a binomial, the alternative would be just to write 2x minus 1 times 2x minus 1 and FOIL it all out, and you'll get exactly the same answer. Okay, on the other side, 2x plus 1 quantity squared, we're going to square the 2x, which is going to give us 4x squared. We're going to square the 1, which leaves us with 1, and the middle term will be these two multiplied together, doubled, because we're going to get two of them, one from the inners and one from the outers. So 2x times 1 is 2x, doubled is 4x, and since this was plus, our middle term is plus. Now we're ready to combine some like terms. Over here on the left side, I'll get 5x squared minus 4x plus 1 equals 4x squared plus 4x plus 1. And now we're ready to get our 0. We want to move everything over to one side. So I'm going to move all my terms on the right over to the left by subtracting them. And that way I'll get a nice positive leading term, and my 0 will be on the right side. So 5x squared minus 4x squared is x squared. Negative 4x minus 4x is negative 8x. And plus 1 and minus 1, those cancel each other out. So we end up with x squared minus 8x equals 0. Now, a lot of times students have trouble identifying how to factor this. There are only two terms. There's a difference in between them. And we have a perfect square in that x squared, but 8x is not a perfect square. So we're not going to be applying the difference of squares pattern. So the only other option, if this is going to factor, is there must be a GCF. And since they both have an x in them, there is a GCF. I can pull out an x, and when I do, I'm going to be left with an x from that x squared, and I'm going to be left with the minus 8. And now we're ready to set each of these to 0. If I set x to 0, I'll get one solution, and if I set x minus 8 to 0, I'll get positive 8 for another solution. Now remember, with word problems, sometimes your solutions that you get don't always work because of the context of the question. So we need to double check these. If x were equal to 0 and I were to plug that back in over here, the short side would be 0, which kind of doesn't make a whole lot of sense because then you wouldn't have a triangle. And if I put 0 in for the longer leg, we'd actually get a negative 1 length, which doesn't make sense at all. So in this case, x equals 0 is not a valid solution because it doesn't give us a proper right triangle. If we use 8, then the short leg would be 8. 2 times 8 minus 1 would be 15, so the longer leg would be 15, and 2 times 8 plus 1 would be 17. So we would have an 8, 15, 17 right triangle. So that's a valid solution. Now make sure you're answering the actual question that's being asked. We were asked to find the length of the shorter leg. So the shorter leg was the side 8. And when you're solving word problems, you want to write your answer in a sentence. So we could say that the shorter leg has length 8. And the units up here we're referring to feet. So this would be 8 feet. And there's our solution. Okay, in our next example, we're going to talk about a very common type of problem in mathematics. And this is the kind of problem where you're taking an object and you're throwing it upwards into the air. And when you do that, we're going to sort of simplify the problem slightly and just assume that that object is only going to be acted on by gravity. And when you have gravity acting on an object, you get height functions that have this kind of form, a nice sort of quadratic height function. So these are pretty common problems in mathematics. So what we have is an object that's propelled upward from a height of 48 feet with an initial velocity of 32 feet per second. Its height h is given by this equation. After how many seconds is the height 60 feet? So just to kind of visualize this, here's hill or building or whatever we're standing on that's initially 48 feet tall. We're standing up here at the top, and we're going to throw this object up into the air, and then eventually gravity is going to pull it back down to the ground. And the initial velocity that we're throwing it with is this 32 feet per second, and the initial height was that 48. So here's your 32, here's your 48, and this negative 16 out front comes from that acceleration due to gravity. It's actually half the acceleration due to gravity. Now, you don't really need to know where all this stuff comes from. You do need to know how to use this to answer the question. So we have this height function, and the question is, when is the height of the object going to be 60 feet? So at some point, this object is going to be 60 feet off the ground. And we want to know, when does that happen? So if you think about this equation here, it gives us heights and times. So 60 feet, is that a height or is that a time? It's a height. So we are going to plug in 60 for h. So we're just going to put 60 on this left side, set it equal to our equation, and now we have an equation in terms of the variable t. So when we solve here and figure out what t is, we're finding times. So here's our equation. Now to solve this, we would want to get a 0. So if I try to get a 0 by subtracting 60 over to the other side, then we're going to get 0 equals negative 16t squared plus 32t, and 48 minus 60 is going to be negative 12. Now on the right hand side here, we have a trinomial, 3 terms, so we'd like to use reverse FOIL. But before we jump into that, please notice that all of these coefficients are even numbers, so there's probably a GCF of at least 2 that we can pull out. And another thing to consider is this leading term is a negative 16. Having a leading term that's negative sometimes makes factoring tougher to do. So what I would suggest is factoring out not only our normal GCF, but also factor out the negative as well, so that what we're left with will be easier to factor. So first we need to think of a number that divides into 16, 32, and 12. And the answer to that would be 4. And I'm also going to pull out the negative as well. So negative 4 is my GCF. In parentheses, what would we be left with? Well, negative 4 goes into negative 16, positive 4 times, so we're going to get a 4t squared. Then we're going to have negative 4 goes into positive 32t, negative 8t times. And negative 4 goes into negative 12, positive 3 times. So what we're left with is still a trinomial, but the numbers are slightly smaller, so hopefully it's going to be a little bit easier to factor. So let's try our reverse FOIL. I'm going to leave that negative 4 out front for now, and we're going to set up our 2 sets of parentheses. We need 2 things that multiply to 4t squared. So I know I need some t's, and the way I could get 4 is either with a 2 times 2, 4 times 1, so there's a couple options there. On the other side, we need 2 numbers that multiply to 3. There's only one way to get 3 times 1. So since there's only one choice for that, I'm going to fix that to be 3 times 1. And in front of these t's, I'm going to list all the possible ways I can get 4, including all possible orders. So this could be 2 times 2, 4 times 1, or 1 times 4. And to check this, remember we're trying to get a middle term of negative 8, so we're going to see that from our outers times our inners. So if I do 2 times 1, we'll get 2. And if I do 3 times 2, I'll get 6. Can I get an 8 from a 2 and a 6? You bet, just add them. Or actually in this case we want a negative 8, so I want both of these to be minuses. So I'm going to put a minus in front of my 3 and a minus in front of my 1. So we have this factored now. We got a negative 4 GCF out front, and then the numbers that worked were 2t minus 3 times 2t minus 1. Now don't forget to finish solving all the way. You don't want to stop after you've factored. Now we need to set each factor to 0. Now this -4, this does not have a variable in it. There's no t next to that -4. So -4 is not going to contribute anything towards our solutions. So if you have a GCF, which is just a number and no variable, you can ignore it. It's not going to give you any solutions. So only this factor and this factor will be able to be something I can solve for t. So let's set them each to 0. And if I add 3 and divide by 2, I'll get 3/2. If I add 1 and divide by 2, I'll get 1/2. So I get two answers. T equals 1/2 and 3/2. And remember what we were solving for here. These were times. So these are in seconds. And does it make sense in the problem that we're getting two solutions? You want to consider that. So if we go back over here to our picture, it should make sense that we are getting two solutions, because after half a second we're going to hit 60 feet, and then on the way down we're going to hit 60 feet again. So we have half a second takes us to the first time we hit 60, and 3/2 of a second takes us to when we hit 60 feet the second time. So we hit it on the way up and then on the way down. So in this problem, our solution would be that we hit 60 feet at 1/2 and 3/2 of a second. Okay? Now in the dealing with the same equation, the same situation, let's ask a second question related to this. It can be shown that the object reaches its maximum height after 1 second. What is the maximum height? So remember our equation from earlier. H equals -16 t squared plus 32t plus 48. So this time we're told that we reach our maximum height after 1 second. What is the maximum height? So we're looking for a height. We're looking for h when the time is what? Well, when the time is 1. So this 1 second is a t. So we're going to take 1 second and we're going to plug it in for t. And that'll tell us what h is. So in this problem, instead of plugging in for h and solving for t, this time we're plugging in for t and solving for h. So we're going to leave h alone, plug in 1 for our times, and you can do this on a calculator, that's perfectly fine. We're going to get -16 times 1 is just -16, plus 32 plus 48, and we get here 16 plus 48 equals 64. And the units on this, remember what we were just solving for? We solved for h, which is a height. So this must be 64 feet. So the maximum height reached is 64 feet. And there's our solution. Okay, in our last example here, this is also a very common type of problem that you see in most math textbooks. A lot of times it's assigned for homework problems. So we're going to try one of these. It's the box problem. Here we have a box with no top. Is to be constructed from a piece of cardboard whose length measures 6 inches more than its width. The box is to be formed by cutting squares that measure 2 inches on each side from the 4 corners, and then folding up the sides. If the volume of the box will be 110 cubic inches, what are the dimensions of the piece of cardboard? So first you have to understand how this box is being constructed. What we're doing is we're starting with a piece of cardboard, so just a rectangular piece of cardboard, and what we're going to do to it is cut out little square corners. So if you imagine cutting out those little corners, what you'd be left with is a shape like this. Then what we do to construct our box is we're going to fold along these little dashed red lines. and these become the 4 flaps, and we're going to fold them up on all 4 sides. And when we do that, we tape them together and we get a box. The box doesn't have a top, it's open on top, but the 4 sides are coming from these 4 flaps, and the base is this red rectangle in the middle. So that's how we're kind of constructing our box. Now let's fill in some dimensions here. It says that the box is constructed from a piece of cardboard whose length measures 6 inches more than its width. So if we call this side the width and this side the length, it says the length is 6 more than the width. So the width would be the side I need to know first, so let's call that x, and the length would be 6 more than that, so x plus 6. Then the little squares that we're cutting out from each side, these are 2 inches on each side. So this is a 2 by 2 square that we're cutting out. And when we fold up our flaps, we end up with this new box, and it tells us that the volume of the box will be 110 cubic inches. So think about the volume of a box. How do you find the volume of a rectangular prism like this? Well, you need to know its length, its width, and its height, and volume equals length times width times height. So if I can find these 3 dimensions, I'm just going to multiply them together, and that has to equal 110. So that's how we're going to get our equation, but first we need to figure out what the length, the width, and the height are in terms of these original x's that we had over here. So let's start with the height first. The height comes from folding up these little 4 flaps. And if you think about our little squares that we cut out, this was 2 by 2 by 2 by 2 all the way around. So when you fold up one of these flaps, how high up is it going to go? It's going to go up 2 inches. So the height is just 2. Okay, that's the easy one. Now we have to get the length and the width, which are a little bit tougher to see. So to get our length, or let's start with our width. To get our width, we're going to start with this initial length here, which is what was x originally. And the new width comes from the width from here to here. So what did we do? We cut off this little length and this little length, and what we're left with is this new width right here. So how do we go from the original x down to this little orange length right here? Well, it's the original x minus 2 and minus 2 more. 2 from the top and 2 from the bottom. So this new length is x take away 4. So the width is x minus 4. To get the length, we're going to do something very similar. We're going to start with the original length, which was x plus 6, and the new length comes from taking away 2 from the left and 2 from the right. So we're going to take away 4 again. 2 from the left and 2 from the right make a total of 4. So we're taking 4 away from the original length of x plus 6. So that would be this length right here. So it's x plus 6, take away 4, and if we simplify that, that gives us x plus 2. So the new length is x plus 2. So we have our height is 2, our width is x minus 4, and our length is x plus 2. So all we have to do now is multiply all 3 of those together and set that equal to 110. So here's what our new equation looks like. The length, which we said was x plus 2, times the width, which we said was x minus 4, times the height, which was 2, and that volume needs to equal 110. So we want to solve this. There's a couple ways to simplify this. Remember, we want to sort of get rid of all these parentheses so that we can clean up the problem, and we want to get a 0 on one side. Now you could actually have these lengths, widths, and heights in any order that you wanted. So sometimes if I see just a constant 2 like this height is, I usually like to put those constants out front. So this could be rearranged to look like 2 parentheses x plus 2, x minus 4 equals 110. So these can go in any order that you like. Now you have two choices here. You could distribute that 2 across and then distribute your x plus 2 and x minus 4 factors. Or, in a problem like this, one simple thing to do is just to immediately divide both sides by 2, since 2 is going to go in nicely on this right-hand side. 110 divided by 2 is 55. And that gets rid of that 2 out front right away so that we don't have to worry about trying to distribute it incorrectly. So now on the left side, we have just a simple FOIL problem. So let's go ahead and FOIL. X times x is x squared, and we get a minus 4x, then a plus 2x, and then a minus 8. Combining like terms gives us x squared minus 2x minus 8 equals 55. And now we're ready to get our 0, so I'm going to subtract 55 to the left side, and I get x squared minus 2x minus 63 equals 0. Once we have our 0, we're ready to try and factor. So this is 3 terms, so I'm going to use a reverse FOIL. I only need x's in the front to get x squared, and then I need 2 numbers that multiply to negative 63 and at the same time add to negative 2. Well, 7 times 9 is 63. If I make the bigger number 9 negative and the 7 plus, then plus 7 minus 9 is negative 2. So that'll factor correctly. So we have it factored. Now we're ready to set each factor to 0. So one solution is negative 7, and the second solution here is 9. And remember, this is a word problem, so there is a context. So if we go back to what we were talking about, this was our boxes. Doesn't make sense for x to be negative 7. It can't, because x was the length, or excuse me, the width of the original piece of construction paper. So you can't have a negative width. So down here in our solution, negative 7 is not valid. If x is 9, then this width would be 9, and the length would be 9 plus 6, or 15. So the final answer here, remember they were looking for the dimensions of the piece of cardboard, so that's the original length and width of the original piece of cardboard before we cut out our squares. So the dimensions are 9 by 15. So let's just write this in a sentence. The dimensions are 9 inches by 15 inches. And the units are inches because the volume was given in 110 cubic inches. So we're going to be consistent. So here's our solution. Alright, that concludes our lecture on solving equations by factoring. Good luck.